Hi all, my name is Abhishek and today we are going to talk about MySQL replication and scaling. So this is gonna be our today's agenda. We are starting with a brief introduction about replication and for the sake of this seminar, we I have installed a multiple instances of MySQL server. So we're gonna talk about that a little bit, and then we are going to see how a replication works with the demo and troubleshooting replications and how that helps us scaling out our systems and a sort of replications utility for the high availability systems and the fault tolerance. So let's get started. So a replication means a capability of one server being copied over to another server. The master the server is being copied from is called the master server, and the target server that that gets the copy of the the master server is that's called the slave servers. Okay, the replication was first introduced in a version MySQL version 3, and later on it's been much improved, and we have a much improved and advanced version of MySQL replication. So this is how it works, the MySQL replication. Okay, we have a master server, and the master is writes everything to a binary log file, and the binary log file has all the events that master executed in its own server, and the slave gets all these events from the master server to its relay log, and it replicates everything to its own hosts. Okay, and it's not necessary, usually it's not necessary that the master and the slave servers have to be on the same host. It 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 can be a different host. Actually, it makes more sense to have on a different host. Okay, so for the sake of this presentation, I have a multiple instances of a MySQL server installed on my system, but it makes more sense we have replication working on a different host from the source host, for obvious reasons, like in case of in case of a server failure. So we can have a backup working that's on a slave. Okay, but there are a couple of reasons that we need multiple instances on the same host. Okay, for a new server release, and we don't want to disturb, we have to check all this the new server the functionalities before it go live, before we put it live, and we can do all sort of administrative work with this all the functionality. Okay, and we have to make sure that all this functionality works fine with our system. But there are a couple of some precautionary steps that needs to be taken care of. First is we have to have a separate data directory for each of the database instances, and both the instances should not interfere each other, right? Like it should not it should no it should talk to different host, if it should talk to different port, sorry, if it's on a same host, yeah? And it also have to have different socket files and a log file or a PID file. And we have to, it should have a different log file or PID file, otherwise it doesn't make sense. And here we have an image how MySQL replication really works. So we have three main threads working at the back end of replication. So we have a server host that we have on the left hand side, and we have a slave host on the right hand side. See, So what happens is, between these three threads working asynchronously, one thread is working on a master side, and that the task of that thread is it writes everything, all the MySQL events to the binary log file. Okay, and the two threads that works on a slave thread, one is called the input output thread and other is called the relay log, other is called the SQL thread. The task of the input output thread is it connects to the master host and it reads the all the events written to the master's binary log file. Okay, and it just takes that all the events and it writes to its local file, slave's local file, and that calls the relay log. And the other thread, the SQL thread, the task of this SQL thread is it reads all the relay log file events written by the input output thread and takes executes all the events to this slave databases. Okay, and all these threads runs asynchronously, so nobody is waiting for uh, other to finish up the task and all. So we are going to see a demo how a replication works here in my local. So but this is uh, an abstract steps that we are going to follow. First is if we have to have another replica of a master slave of a master's database, then we need to sync the databases. We need to sync both the databases at to its initial state, to its initial state, and then on we can point a slave server to point it to a master, so that it takes all the events executed on a master and it also replicates to the slave as well. So let's see how that works. So this is my master. So this is my master MySQL server running on a port, running on a PID is 1406, and I have another instances of MySQL that that's called sudo etc NOT, that's called MySQL 2. Okay, and both are running. Now my task is uh, our task is we need to make the MySQL as a master of the MySQL 2. So we need to point the MySQL 2 to connect to MySQL and do all this, start the replication process. So what I have done is I have taken the dump of the MySQL, okay, from the MySQL database and dumped in, and that's an easy task. Okay, we can use a MySQL dump to dump out any of the databases that we want to replicate, but it's always recommended to do all to dump everything, every databases, and we can dump in to the target database. Now couple of configurations we need to check is go to the binary go to the configurations file, okay, of the master, and search for the binary log, if this binary logging is enabled or not. log bin is enabled and it's pointing to some location, and it also has to has a unique server ID. Okay, that's a because that's an important step. So on a server configuration, I have to check if the binary logging is enabled, and also it master and slave every instances of MySQL has to have a different server ID, a unique server ID. Okay, then on a master side I need to create a user so that a slave could connect to to this to the master as this user, and it also the user also has a replication privilege so that it can start up the replication process. So that's all for the master configuration. Then I can go into the master and I have also created the user, the slave user. Okay, let's yeah, I have those user so that the slave could connect to this user. Now on a slave side I have to connect to master. So let's go in. So this particular instances of MySQL is running on a port number 3308, and its the socket location is different from what that of master. So that's not interfering with any of the other database instances. So let's go in, and the next thing I have to do is sorry the next thing I have to do is uh, on a slave side I need to point to a master. I need to point to a master and to which master to connect to as a which user will connect to, and what's the password of this particular user, and on which port the master is running to, and the binary log. And there are two other configurations like a master log file and a master log position. Okay, I'll discuss in details in a while. Let's copy and paste this statement. Now the binary log position, binary log file and a binary log position, what this means, these two configurations are called the replication coordinate. Okay, and this tells us the slave server from which location of this particular file, on from which file and from which location of this particular file it will start replicating, it will start the replication forward. Okay, so now where to get these values? So you can get these values from the master, saying so master status. Okay, what this mean is the master is currently is pointing to this particular binary log file and in a position of 120. Okay, and optionally I have also added I've also added a parameter in a configuration file to only replicate the AS01 database, but it's not recommended to adding a filter on a server side. It's always recommended to add the filter on a slave side rather than on a master side. The reason being is uh, unless you are replicating everything on a master side, okay, you always have a provision to do a point in time recovery. Unless if you don't have any of these event written on any of on this binary log files, so there is no scope of going back to any of this previous state if you want to. Okay, so it's recommended to do all these replicate everything on our master side and do all type of filtration on the slave side. Okay, so now the master is pointing to this particular location file size, so I need to copy and I just paste it here, and the location is 120, I guess. So yeah, so that's all. I can save this and then I can execute it. Oh, the master is I'm sorry. Sorry for this, I got this from previous configuration, so I need to reset this slave first. So sorry for that. I have reset the slave configurations now, so I can do I can start this configurations again, this connections again. Okay, slave is disconnected now. Now I can do this. So we'll start with there. As I said, we are pointing to this binary log location. I have to copy from the master and paste it here, and also on this log position size, and that's 120, and we are good with it. Now just run this statement and just type show slave status. So you'll see that we talked about these two slave threads running, and they are not running because we haven't started it. We just configured so that the slave is pointing to the master, the slave host is pointing to the master host only, but the slave threads are not running. So how to make that running is you just type this start slave, and optionally you can start an individual thread by typing a input output thread, okay, or SQL thread. You can simply omit start slave, that will start up both the threads. Okay, so both the threads are running now. Now let's see if that replication works, and that's all we have to do. Okay, let's see if that replication works now. So I go back to the master side and to find a table that we can do a testing. So we have a table called temp, so let's des temp. Okay, now before doing an insert, let's find out what are the contents the temp table is having. Select star from temp. Okay, now we can do an insertion, insert into temp values
my replication inserted row. Okay, now go back to the slave and let's find out if that's being replicated. Select star from top. Wow, it's being replicated now. Now couple of things I need to show to you guys. It's one is when we can check out what are all the slaves is connected to a particular master. So for finding out this, you need to type so slave hosts. Okay, now let's list all the IDs of the slave that it's being connected to. Okay, now the ID is 30 is the ID for the slave, and the slave is running on the port number 3308, and this is the ID for the master server ID, and this is the slave's UUID. Okay, now I have another MySQL instances, and let's start this. Okay, so that we can check if that source slave status works. Okay, I'm starting another MySQL instance slave, and this is a slave of the same master. Okay, now go back to the master that's started. The new instances are successfully started. Okay, now go back to the master and type the same command. Okay, yeah, now it's having a two entries. Okay, and the last entry is for the second slave instance. And one more thing I need to show you two guys is, so we can find out what are go to the slave and we can find out what are the status of the threads that is running on a slave side. Okay, so you can for that you can type so process list, and here you can find there are two threads running. One is this, and for the system users, okay, there are two threads. One is this one process ID and one is the two process ID. Okay, and we can find out which event, which thread is which by reading the states. So the state is stating the waiting for a master to send events, and that means it's interfering with the master. Okay, it's talking to the master, so it must be an input output thread. Okay, and it's waiting for the master's thread to send events, master's binary log to send events to it. And the second thread is slave has read all the relay logs and waiting for an input output thread to update it. So that means it's talking to the relay log, so it must be an SQL thread. Okay, so there are two threads running depending on there are two entries depending on the threads running on the slaves. If we stop any of the thread, the entries goes decreases. Okay, accordingly. Now go back to the master and let's type the same thing. So process list. So we have something called with the replicator user. Okay, that's the slave is connected to via this user. So what it's saying is, it's master has sent all the binary logs to slave and waiting for the binary log to update. Okay, that means there is there is no new events that's being written on a binary log that could be sent to the slave. And other things that you can see on a master side itself is the same thing that we have seen on a slave. That's because I have made this master to be as a slave for the MySQL one. Okay, so I have set up around replication. So MySQL is a master for master one, and MySQL one is the master for MySQL. Okay, that's because it's around replication.
Now I'll go back to slide. So these are all the steps that we have seen as a demo. Okay, and optionally we have another configurations that we can do on a slave side. We can point a relay log file positions to point to a location, our desired location where we want. Now it's also possible, while trying setting up a replication, we may face some of the troubles. So how we can troubleshoot the replication is, first of all we need to see if that master is enabled with a log binary log enabled, because that's the core of it. If the whole replication process is just running with a binary log, so we can check that the binary log file with a show variable like log bin on a master side. So let's see if that is enabled. So it says binary logging is enabled on a master side, but that's not mandatory. The binary logging is enabled on a slave side as well, but for the master side it's mandatory. And the next thing is, um, if the starting up the slave threads, each of the slave threads, uh, we see there is an error information, or as error slave so slave status uh, output, output format, you know there is a column called error information. Last SQL error occurred, and last SQL error number. So we can check out these columns while starting off the individual threads. Okay, and the most important that I found very useful is finding out is checking off this monitoring the slave the logging error logging file, because a couple of times I had an error and I found the relevant information in the log file itself. And if that connection if that we have a proper user and having a proper privilege, that we can check with the master, we can connect with connecting the slave connecting the MySQL server with the slave from the slave host as a client, MySQL client itself. Okay, if we can if that we can connect to master server with that particular user or not. And there is also a couple of things to note with the compatibility and upgrading the server, each of the individual servers. So the important thing is, the core thing for the replication to work is, if the slave will be is able to read and pass all these SQL events written on a binary log file. So the server if the MySQL server on a master host is of higher version, something of some of higher version like 5.5 or 5.6, and the slave is having a lower version of 5.1. So this the binary log format is keep on changing, and the events that's being written on a 5.6 master, the slave could not be able to decrypt it, decode it, and that ends up with an SQL error, or something like that. So as a general statement, it's recommended upgrade the slave, okay, before upgrading the master to a later version. And it's also it's the best practice, the compatibility best between the master and a slave will happen the best if they both runs on the same MySQL version. Okay. So where the MySQL helps us the most is it helps us scaling out our applications horizontally, let me call it. Okay. uh, you can see from the picture here. So we have a one MySQL master, and that's being replicated to multiple slaves. So we can have a multiple slaves being replicated from a same master, but we cannot have the reverse. uh, Two masters cannot point no, one slave cannot point to the two masters, I'm sorry. Okay. So it needs to point to a one master. It can only have one master. And the how that replication helps in scaling out our application is so we can have a multiple slaves working parallelly with a master, and all the read request will goes to the slave 1, slave 2, and slave 3. So we can distribute the reads coming out to a web application, as most of the web applications are mostly of read based, and less of writes. So we can distribute the read loads to the several slaves itself. Okay. While the master handling the writes, because that the master only can have this can only handle the writes. So here it how it works. The master can handle the writes, and each of the clients, each of the wave clients is connecting to different MySQL instances based on if it's a write or a read. If it's a write, it goes to the master, and if it's a read, it can connect to any of these hosts. Even master can handle the reads as well. So this way we can have increasing number of slave, and that the system scales out. So this is how it behaves as in a graph. If we have uh, if we have a one master, if we have a one slave, and that is approximately that supports simultaneously it can have a 200 rates. The system can do a 200 rates. Okay. And now with the increasing number of slaves, the number of writes and the scalability scaling out. Okay. The system is scaling out. And the another application where this MySQL replications helps us the most is the backup. It can act as a backup and a fault tolerance or high availability system. Like if we have a multiple if we have a multiple slaves working parallelly with the master. So that means we have a exact, it's almost of exact replica on these different hosts. So in case of any failure, something has strong, and if master went down, so any of the slaves has a capability to works as a master till the master come back again. Okay. So this way we can guarantee that the system will have a high availability, and it will it will with it will act as a backup as well. And So this is how we can see in a picture is suppose two of the web clients is connecting to the master, and the master have three slaves, slave 1, slave 2 and slave 3 working in a parallel. Now in case happened, what happened is master went down, okay, and we have to point to any of these slaves. Say suppose slave 1, we are promoting the slave 1 to act as a new master, okay. Now how that's done is, so we have this all these steps here, okay. Now we have a variable called global variable called heartbeat, okay, slave heartbeat period. So what that does is when that variable is set, we can set it to any number of seconds we want to, and what that does is the master sends a heartbeat to that to a slave in that particular interval of time, in every that particular interval of time. So if that comes, keeps on going, it keeps on coming to the slave, that means the slave, the master is alive. And with that when that stopped coming to a slave, the slave will come to know that okay, something has wrong, something went wrong with the master, and master went down. So we can carry out all these operations. We can carry out promoting the slave 1 to act as a new master. So we have to stop the SQL thread to each of these each of the slaves, okay, so that nothing nothing has left in a relay log to be written in a slave host, okay. Now if we want the slave 1 to act as a new master, we have to stop the slave threads on a slave 1, and we need to reset master. And what reset master does is it removes the change master command that we have seen while setting up these replications, and it just deletes this change master statement from the slave 1 host. So that means that this particular host is not pointing to anybody, so it's no more a slave of anybody, okay. Now on the next step, what we have to do is slave 2 and slave 3 just stops the threads from slave 2 and slave 3, and we have to re-execute this change master, and this time the master host will be the slave 1 and not the master 1, okay. So now the slave 2 and slave 3 is pointing to slave 1, and just start the slave server from the master 2 and master 3. Now tell every web client to connect to slave 1 now, rather than pointing to the master, okay. And it's obviously there is a note each of the while we start the slave server, the binary logging is also enabled to all the slaves that we may promote to acts as a master, okay. In this case the slave 1 may works as a master, so binary logging must be enabled to the slave 1. And this is how it ends up with after after we promote the slave 1 to act as a master, okay. Now slave 1 is a master now, and master it's a failed master, and web clients are now connecting to the slave 1, and the slave 2 and slave 3 is a new slave of slave 1, okay. Now the important thing to note here is, now after some time master come back, okay. Now we have to make the master as a slave of the slave 1 before it's being again promoted to act as a master. The reason for this is that it may missed out all the before transactions, all the events that happened during its failure, okay. So it needs to be in sync before we proceed on to promoting this master as to access a new master. And once that all this the master being synced with all the events, we can repeat the process. Okay.
Huh? Uh, we have to follow these rules. No, we have to write it. We can monitor it. We can monitor the heartbeat. We have to monitor it if this particular master went down. Okay, and then we have to follow. We have to promote which of these slaves to be as a new master, to work as a new master. Right? If say suppose we want to promote a slave 1 or maybe slave 2 or slave 3, maybe any of them as a new master, then we have to reset this master, because we have to delete this statement from this particular slave, because it's pointing, if it's pointing to someone else, master 1, at it was pointing, so it acts like a slave, isn't it? So we have to reset this master. That means we are removing this particular event, this statement. So it's not pointing to any of this master, and it any of this master, and it acts as a master. So we have to write the scripts. Yeah.
Is there any tool that handle this automatic things when there is a failover?
Maybe there are tools available, but these are maybe there are tools available, but these are the things that have to do.
I heard there are tools available, but you have not researched about it.
Yeah. So and that's all.
Unless there is no automatic failover mechanism which will switch over automatically once a master fails. In real time, there will be no use actually. And if you are using a master slave, you have a master and you have multiple slaves working there. And if master fails, then everything goes down. And if you do these changes manually, then it will take some time. And
Yes, sometimes it has to be. It has to be sometimes.
Availability will be going down.
Yeah.
So yes, it can keep checking. Actually, those tools.
Yeah, we have a variable called.
Actually, there are tools available. I have
Yeah.
not researched about it, but I heard there are tools available.
Yeah, there are
You can
tools
do
available.
This kind of setting. Actually, those tools do those kind of things. They have kind of them. They just in each 2 second, 3 second, they do health check of master and slaves.
So we have this variable called slave heartbeat period, slave last heartbeat, when it last heard it. Okay, so we can set this particular interval with a variable, with a value. Here it is. See, change master to master heartbeat period is 1. This is of everything in the second, and is having, it also counts the
What it does actually, a master to master heartbeat period is equal to 1. This is for what?
what the, when
Change master to master heartbeat period is 1.
master to master underscore heartbeat period, this is a variable name.
So what it signifies?
This signifies the master sends intimation to all the slaves in this particular slave, sorry. Yeah, it sends a heartbeat, kind of, I'm alive, I'm alive, I'm alive. So that's it. If you have any question. It almost real time. That depends on, mostly it is SQL thread that creates the more issue, not the input output thread. If it's an input output thread, then we have to take care of if you're having those now if you're having those hard disk or memory of having of less input outputs, now IOPS, right? So it's more of SQL thread that's responsible for this lagging, right? Not the input output thread, very less.
I think he's asking about the replication lag. There is some replication lag between the master and slave. He's asking, can you increase or decrease it?
Lagging?
Yes, that replication lag.
Can we set a duration like after 5 minutes the slave will be updated?
You want a slave to be updated after
Every 5 minutes the slave will be updated.
it will be updated. Yeah, it's almost real time, unless we run some kind of bulk SQL statement or some kind of a dump and all. It's almost real time.
In case of the transactions,
Huh?
yes, there is
Some
replication lag.
milliseconds
There
or
is always a
microseconds.
replication lag, but he's asking about if you can increase that lag.
You
Or
want
decrease
to
that.
intentionally increase that lag.
That's he's asking if you can. Yeah, there is no advantage, right?
I mean,
There is no advantage in it.
a replication means of having of exact replica, and
Yes.
it doesn't make sense if we want to do it
Yes.
after 10 minutes. Why you want to do it after 10
There
minutes?
is a
Yeah?
replication lag actually. There is no meaning of using replication. You can have a cron running which will take backup of your database periodically.
Yeah.
Abhishek, like when master will go down, you will lose some data. Like the slave will be not safe with the master. When the master will go down, like that updation will be not there in the replica server, this the slave. Then what will happen? What are those data? How we can see?
If master went down, that means it couldn't execute those statements on master itself. If it does, we are stopping the input-output thread, right? That means the replica coordinates will still be at before that happens, that fail happens.
The question is, if the master server goes down, fully crash, then what will happen? You cannot see those data here. The binary log you are writing in the master server, it will not.
It could not send.
And then what will happen? Then you will promote a slave server as a master. But those data is not seen in the slave servers.
Yeah, I mean, how could if master went down, that means it couldn't execute those statements on a master itself.
No, the system crashed.
There is 1 to 2 second delay, right? Let's suppose 2 second delay. So let's say master, you have executed one statement in master.
Master is alive.
Instantly it goes down after executing the statement.
Okay, I mean, just what I'm saying, it's almost real time. It's almost real time. Yeah, there could be 1 or 2 statements that couldn't be executed.
In this situation, the server is at one place. Where replication will be done, the server will be separate network. It's a separate.
The thing is,
There will be a delay.
this should not be a replication server installed on a different geographical location.
No, that is okay, but there will be a network lag.
In fact,
Which a few
that
seconds
might be
will
the
be
reason
there.
is why you said.
That's-
Filtering should be done in the slave server.
Huh?
Suppose you are filtering in the master server, then it will take some more time. If
And
suppose you are filtering in the slave server, then it will be faster.
Come again?
You previously have said something like this, filtering should be done in the slave server.
Yes.
If suppose we are filtering in the master server, then it will take some more time. So if suppose it is filtering in the meantime, it got.
It's not that we are adding a where clause and all, is input output. So it's quite faster. It's quite faster. It's not that we are adding those binary log in those filtering in a configuration file. That doesn't make it it will add some delay or add some lags to it. Yeah, it's possible we lost some of the data, but it's real time almost.
Okay, but let's say if there are few binary logs which was not synced. So when master
Few binary logs, that means it's lagging to many seconds.
I mean, let's say there are some logs which is not
Some of the events not being sent.
being synced. So when master come live again, will that be synced?
No, we have to execute that statement, that change master, right?
No, this is not a question. He is saying like when the master is going down, it has some data written
No.
data means
No.
back to the slave.
No. No, see, I've see, when we start a slave, we have to write this, we have to execute this on a slave. So that's pointing where this particular master log file is pointing currently, and what is the log position. So that means we have to point it again. What is current master is pointing to.
The data is not recovered. When it crashes, the data will not recover. Is that moment of time? If it happens.
Yeah, if it happens, so no, there is no way.
Can we like manually change out of the data which is not string?
And manually we can do everything.
Yeah, manually it's kind of nice to get access to that. You can do that.
We can do everything manually.
Can you go to that slide that you were showing about
Yeah.
read, replica, and master?
Yes, sir.
No. You can check on back. When you're showing the master slab and where the load balancer is on. Here. Here, client writes to the load balancer.
Client, no, not, yeah, kind of. So load balancer here,
Obviously,
That
client
helps.
can read from the load balancer.
yeah, that helps to which of the host it will point to.
No. Suppose I'm writing my application, okay? I will pointing to whom? I will pointing to directly
That
master
load balancer does.
load balancer, right?
Yeah, I mean that kind of script does. To whom it points to. Say suppose we have an application where we write something, okay? We write something, we insert invoices, sort of invoices, and we have another section for all these reporting stuffs, doing all these operations on reporting and finding out statistics. So those reporting stuffs can point to any of these slaves.
No, in your application, you do connect to your MySQL, right? In this case,
So we
to
point
whom
to
you
some
connect?
different host.
To which server you will connect? It will be a load balancer, or it will be that master.
Load balancer just helps us to connect to any of these slaves.
How it helps? My question is, I will keep my host and username password.
We need to divide it, we need to balance it.
Then
That
why
load,
load balancer gone here?
why?
What is the load balancer role here?
It helps us to divide. Say suppose we have a lot of select queries running, okay? Then it helps us divide the select queries to, not equally, but approximately to different slaves.
Suppose you are doing an application, and suppose a registration page, okay? You have to enter your data, you have to get some data, okay? In your application, you are connecting to some host, right? Some MySQL server, okay? You are giving the username and password and IP port and whatever. Okay, you are connecting to some MySQL server, okay? Suppose if it's a write, you are connecting to master itself. If it's a read, you are connecting to the slave itself, okay?
Yeah.
Two different script you have. Okay, for art you have a different script, for edit you have a different script because you are getting that. And where is the load balancer here? If there is a load balancer, then where you have to connect it? You have to connect to the master or slave, or you have to connect to the load balancer itself. You ignore the master and slave because the splitting of things will be done by the load balancer. Load balancer will check whether it is a read request or a write request. Then accordingly, it will split the query among, it will direct the query to a master and a slave.
Yeah.
Understand? If there is a load balancer, I will just write my query to the load balancer, irrespective if it is a write or read.
No. We are not writing anything to load balancer. We have to connect to a particular, any of these hosts to get the work done.
Then where load balancer came?
Okay, we can call it anything. You can call it anything. I'm just calling it a load balancer.
Is for web server, it is not for MySQL server. So it only distributes the client load.
It just distributes which of these particular instances we have to connect to.
On the web server, you have your code, right? Application. So there you will decide which server to connect.
In the load balancer, if it is for a MySQL server, if it is for a web server, okay, each web server has its read and has its write, right?
Yes.
Then each web server will have to connect either to master or to slave.
Yes.
for web server to database server, there is no load balancer.
No.
Load balancer.
That is no. From web client, that is actually the your web server to MySQL-Slave. There is no load balancer.
Okay,
It is not one connection.
Okay, here the web client is directly connecting to the
Yes.
either to master or to slave.
Yeah. We have one
The
script.
client is connecting to the load balancer, which is a web server.
That kind of architecture also we can.
Yes, there is. I know there is some kind of splitter available. I have noticed. Yes, some kind of access proxy, high available proxy, and some product also coming in for this kind of MySQL splitting. Just it is a load balancer kind of thing. I have not researched more about this. I'm just asking if you have researched about it.
It is available for MySQL.
It is available for MySQL also.
It is ID.
It is available for MySQL also. You can have. You just need to connect to the load balancer. Load balancer is itself for my database server, not web server. Load balancer for web server is different. MySQL server.
There are so many products available. Scale base that does the same thing.
Scale base, exactly. That's it. In this, you have to connect to the scale base itself. It will take care of everything.
Yeah.
So that's all for this presentation. So I have this reference taken this reference from MySQL's official site, and thank you for attending the seminar.